These partial fractions problems can get pretty tough. I'm going to go through one additional example on video. I'm really going to hope that most of you can go to the website link that I've provided for kind of higher end examples because these problems do tend to take about 10 minutes apiece, and it's very tough to make 6 or 7, and nobody wants to sit through a bunch of 10 or 15-minute videos. So trying to keep this as brief as I can. So we've looked at situations where you have linear factors and you just end up with a constant over each term. If you have repeated factors, you have to include every single possible power of that. So I think in one video, for example, we had an x minus 1 cubed. You had to have a denominator of x minus 1, you had to have a denominator of x minus 1 squared, and you had to have a denominator of x minus 1 cubed. Okay, what we have not looked at is what happens if you can't get linear terms. What happens if you have an x squared term in your denominator or something like that? And that's what's going to happen here. So if you factor this denominator, you can only factor out an x, and you're going to get an x times the quantity x squared plus 4. Okay, this is not a difference of squares, it's a sum of squares. It's not going to factor. And so the question is, how do we deal with this with partial fractions? Okay, there's a decent amount of theory behind this that I'm not going to get into in this video. But long story short, if you have a linear term in the denominator, you'll have a constant in your numerator. So if you have an x as your highest power, your numerator will just have a constant. Okay, if you have a quadratic in your denominator, you can have up to x to the first in your numerator. If you have a cubic term in your denominator, you could have an x squared term, an x term, and a constant term in your numerator. All right? So here's how this is going to work. This is going to break up. We have a linear term. We're going to have a over x, some constant over x. We have a quadratic term that doesn't factor down, and as a result, that's going to be our other part of our denominator here. You're going to have the possibility of having a linear term, an x term, so a bx, and you're going to have the possibility of having a constant term, so a bx plus c in your numerator. Again, if it was a cubic, unfactorable cubic in the denominator, you could have a bx squared plus cx plus d, square term, x term, constant term. Basically one power lower than whatever your denominator is, okay? From here, the process is very similar. You can multiply the numerator denominator, or you can multiply by the common denominator. So here we're going to multiply by x over x squared plus 4. Okay, and that's going to cancel the denominator. We're going to multiply by x times x squared plus 4 here. That's going to cancel just the x. And we're going to multiply this numerator here by x times x squared plus 4, okay? That's going to knock out the x squared plus 4 term. So what do we end up with? Well, we're going to end up with a 2x squared minus x plus 4. It's going to be equal to, you're just going to ax squared plus 4a here. Here, you're going to have an x being multiplied by each of these terms. So you're going to have a bx squared plus a cx, okay? And just like before, you're going to multiply, you're going to match up all your x squared terms, you're going to match up all of your x terms, you're going to match up all of your constant terms with the original equation. So our x squared terms, we have an ax squared, we have a bx squared. So ax squared plus bx squared needs to add up to be 2x squared. That means a plus b needs to add up to be 2. Okay, we have a negative 1x here. Okay, we only have one x term. So cx is supposed to be equal to negative 1x. So that tells us that c is equal to negative 1. That's nice. And constant terms, well, this one's going to be nice too. 4 needs to be equal to 4a. So that tells us that a is going to be equal to 1. So a is 1, c is negative 1, and a plus b needs to be 2. So that means b is going to have to equal positive 1. And we should just be able to fill everything in here to the original equation. This one, they don't always work out this nicely. You're going to get a system to solve, basically, and solve the system however you want to. However, in this particular case, it's going to break up as a over x, so that's 1 over x, plus b times x, so b is 1, so 1 times x plus c. c is -1, so that's -1, over that denominator of x squared plus 4, okay? And that's going to be your partial fraction decomposition in this particular case. So this example didn't take that long. Sometimes these can take longer, though. But again, the process should be pretty much the same regardless.